This is going to be a lesson that looks at the nature of inverse operations, specifically as it relates to two functions when I'm looking to evaluate things. The first thing I'd like you to do is to please grab a piece of paper inside your notebook, the front cover, and pause the video and try these two problems. Okay, at this point you should have tried this on your own. And let's take a look. So I'm also going to point out that I'm probably going to get interrupted by the PA, and I will try to pause the video, but I might not get a chance to. So the first thing I'm going to do is I'm going to say, all right, well, g of x equals, well, the opposite of adding 12 would be subtracting 12. So I'm going to start with x minus 12. And then the opposite of multiplying by 4/3 would be dividing by 4/3. So that's how I'm going to start my g of x function that will determine the original number. But then I'm asked to simplify the function completely. So if I'm dividing by 4/3, that's the same as multiplying by the reciprocal. So I'm going to multiply by 3/4. Now, because it says completely, I need to distribute that 3/4. Oops. So I'm going to go 3/4 times x. So I have g of x equals 3/4 x. And then I have negative 12 times 3/4. Okay, so negative 12 times, that's a 3. 3, well, that's so ugly. 3/4. Now, I want to remember negative 12 is a whole number, 3/4 is a fraction, but I can write negative 12 as negative 12 over 1. And now I have two options. I can multiply across. Negative 12 times 3 is negative 36. 1 times 4 is 4. Negative 36 divided by 4 is 9. Negative 9. Or I can be like, you know what? Negative 12 and 4 are both divisible by 4. So I'll make this a negative 3, and I'll make this a 1. And then negative 3 times 3 is negative 9. 1 times 1 is 1, and then I get my negative 9. So here is my final function, g of x. Given h of x equals 3x squared minus 7, evaluate the following. The first thing I'm looking for is h of 5. So I'm going to go 3 times 5 squared minus 7. Again, you should pause the video if you haven't worked on these problems already and work on them. So I'm going to follow the order of operations. There's no parentheses here, so I'm going to square first. 3 times 25 minus 7. 3 times 25 is 75. And then minus 7 would be 68. H of 0 is going to be 3 times 0 squared minus 7. Well, 0 squared is 0. 3 times 0 is 0. Minus 7 is negative 7. Now this is the one that if people mess up, they're going to mess up. And I'm going to know if you use a calculator. If you got negative 19, I know you used a calculator and you used it incorrectly. Because I need parentheses around my negative 2 when I square it. I need to think about this as negative 2 times negative 2 is 4. And then 3 times 4 minus 7 is 12. And 12 minus 7 is 5. Cool. Go ahead and open up your packets to page 2. Today we're going to explore the nature of inverse operations. As a reminder, you are still responsible for page 3. I'm going to let that go. I'm not going to pause the recording. The directions on page 2 say, in the table below, choose any number n to place in the first column. Now, we're not going to do this.
All students should be reporting this.
But if we choose any number for n, that means all of our answers are going to be different. And some of these functions, we really need to have a specific value. So what I'd like you to do is fill in the column n with the numbers I have here. Okay. The directions say, evaluate function 1 at n and place the result in the h of n column. So let's do that. I'm going to put 1 into function 1. So 2 times 1 minus 5. 2 times 1 is 2 minus 5. So now that is in the h of n column. Check. I did that. Switch colors. Then use the value of h of n to evaluate function 2 and place the resulting number in the result column. So now I'm going to pick up negative 3 and I'm going to put it in function 2. I'm going to go negative 3 plus 5 divided by 2. Negative 3 plus 5 is 2. 2 divided by 2 is 1. And I'm going to do this all the way down. So what I suggest you do is you pause the video and you try the rest of the rows. Any that you get confused about, just skip and I'll go over them when you unpause the video. So go ahead, pause the video now and try the rest of the problems. Okay, so like I said, you should have tried them on your own. So let's see. This one's not so bad. 3 plus 5 over 2. 3 plus 5 is 8, divided by 2 is 4. Now put the 4 here. 2 times 4 minus 5. 8 minus 5 is 3. Now I'm going to put the 5 here. So I have 5 cubed. 5 cubed, well, 5 times 5 is 25, and then I'm going to times another, oh, that's a 2, times another 5 would be 125, and then 125 plus 2 is 127. So this is a symbol that you might not be as familiar with. It's the cube root function, and it means what number multiplied 3 times gives me this number. So if I go 127 minus 2, 127 minus 2 is 125, and I just figured out that if I multiply 5 3 times, I get 125. Now I have the cube root of 2 times 4. Well, ooh, that's ugly. 2 times 4 is 8. So now 2 times, what number multiplied 3 times gives me 8? That would be 2. 2 cubed divided by 2 would be 8 divided by 2, which is 4. Negative 7 halves times 2 minus 3. Well, negative 7 halves times 2, either the 2's divide out or it becomes negative 14 over 2, which is negative 7. Either way, it's negative 7 minus 3, which is negative 10. Two times negative 10 is negative 20. Negative 20 plus 6 is negative 14. Negative 14 divided by 7 is negative 2. And then the negative in front makes it a positive 2. 2 more. The square root of 2 times 6 minus 3. Well, 2 times 6 is 12. Minus 3 is 9, and the square root of 9 is just 3. 3 squared plus 3 divided by 2. 3 squared is 9. 9 plus 3 is 12. 12 divided by 2 is 6. At this point, you should hopefully start to notice a pattern. The last row, I'm going to put the 3 in. 3 squared plus 1. 9 plus 1 is 10. And then the square root of 10 minus 1 is square root of 9, which is 3. So the question below the table, arg! So the question underneath the table, like I said before I got interrupted again, says, what do you notice? And here's what I notice. I notice that this first column and this last column, they are the same. So I'm going to say that nicer. I notice the final outputs, that's the result column, the last column here. These final outputs are the same as the original inputs. And below this, I want you to write the definition of inverse functions. The definition of inverse functions states, if f and g are inverse functions, then when a value n is input to f, and then that result is input into g, the final result will be the original input. Additionally, when a value is put into G and then that result is put into F, the final result is the original value N. So I'm going to draw you a little diagram. Go ahead, pause the video real quick and write that down, and then unpause it and we'll draw the diagram. So if I take N and I put it into F of X, and then I take that number and put it into G of N, I'm going to get N back. If I take a number and I put it into my G function, and then whatever number comes out of G I put into F, I'm going to get the same result. Your homework tonight is to complete page 3. Please show your work. Please do not use a calculator. There is a bottom to page 3. It's not just this table. When you are done, please check your work on Google Drive.